According to the National Ocean Service, humans have only explored and charted 5% of the Earth's oceans. With so much water and marine life, we cannot use the same mapping techniques that we would normally use on land. XOCEAN is transforming the way ocean data is collected using marine robotics known as Uncrewed Surface Vessels, or USVs. Engaged in hydrographic surveying, they're creating maps, an important service considering 71% of the Earth is covered in water. Mike, how is XOCEAN advancing the state-of-the-art in ocean exploration?
XOCEAN is really a data as a service provider, and the way we're revolutionizing the collection of data is by using our own in-house developed uncrewed surface vessels. The reason why it's so important to be doing that is that we're increasing the safety profiles of actually collecting marine data, and we're doing that by removing the need to have personnel offshore. We're also improving the environmental benefits by offering a solution that is carbon neutral.
Right.
And then finally, because we're able to operate 24 hours a day, 7 days a week with our USVs, we're doing it more efficiently than the traditional methods.
And reducing the impact, environmental impact of the vessels doing the collection.
Yeah, exactly. Because we're such a small vessel and have such a small sound signature, not only are we reducing the potential for impact with marine life, we're reducing our impact on marine life by being quieter.
So on a relative basis, what is the environmental footprint of one of your vehicles versus the traditional crewed vessels?
We produce about 1,000 times less CO2 than a traditional, 1,000 times, yeah, less CO2 than a traditional crewed vessel. And the other side of that is XOCEAN has actually set some ESG goals for ourselves. We intend to displace 1 million tons of CO2 that would have otherwise been produced by traditional operations by supporting and performing the data collection for offshore wind and hydrographic offices.
You've got a whole bunch of technology packed into these uncrewed surface vehicles. What are some of the elements of the technology in them?
The way we've developed the boats is to be highly configurable, highly variable. And so we've designed them to be able to take on any of the similar or competitive commercial sensors that you would see on a traditional crewed vessel. The other piece is because we're completely uncrewed, we operate totally over the horizon. And what that means is that we use satellite operations to allow surveyors and pilots to operate and monitor the boat at all times. So what that really means is that we can have a pilot in Ireland, a surveyor in Malaysia, and a boat in the Caribbean. And they're going to be completely collaboratively working to collect this data.
What are some of the customer applications that you've got out there today?
So we've worked on everything from bathymetric surveying or seabed mapping to asset inspection and environmental monitoring. Our biggest growth sector is really around the offshore wind sector. And so for clients such as Ørsted or BP or Shell that are really leading the renewables revolution, we can do everything from pre-construction survey lays and environmental monitoring for them really early on in the life cycle. And then we can really follow that offshore wind farm straight through its life. And what that means is that once construction is complete, we can then do asset inspection of foundations and inter-array cables, and then all the way through to decommissioning.
One of the most interesting aspects is the maintenance and review of the existing assets as part of the solution you offer. So whether it's pipelines or undersea cables, or in the context of a wind farm, reviewing those assets, how do you provide that solution to the customers?
We integrate everything from multi-beam echo sounders to sub-bottom profilers and magnetometers, all to help us inspect these types of assets. And
so is it a visual inspection?
So we use acoustics to develop essentially a 3D model of what we're seeing, and so we're able to look for things like spans under cables or spans under pipelines, and we're able to quickly assess the condition of a monopile under an offshore wind farm.
I was really surprised to learn about the fluidity of the seabed and how it can change if there's a hurricane or something like that. So you have the need to go and revisit those assets frequently.
The ocean is such a hostile environment, and certainly the power of things like hurricanes have such a large impact on those conditions that there's actually a requirement to go back and survey things after certain levels of storms in places like the Gulf of Mexico.
So right now the vessels are uncrewed out on the water, but there is a pilot for each vessel. What does the roadmap for autonomy look like?
All of our vessels are monitored at all times by a pilot. And, as far as the autonomy piece, I think that the technology is getting closer and closer to being able to provide further autonomy and potentially go fully autonomous. But at this point, there is a regulatory factor to get over, and I think all of the world's governments are currently looking at this and trying to come to the same conclusion around how they see these vessels operating and what's the proper safety solutions for them.
I mean, given the need to collect this data and move from that 5% current knowledge level to 100%, it would seem like autonomy is a necessary element.
Yeah, I think going forward, autonomy is going to be really crucial in this. And really, what you're going to see is that you're going to have swarms of these vessels able to tackle this problem and collect as much data as possible on really, as you mentioned before, a rotating basis, because you're going to have to go back and relook at the seabed as it changes.